Hi everyone and welcome. In this brief video, I will give you a clear and accessible introduction to OWASP Software Assurance Maturity Model, or SAMM. Application security is a challenging topic. Many organizations try to address this with vulnerability scanners, penetration testing, regular patching, just to give you a few examples. While these activities are important, unfortunately, they only cover a small part of the full scope of security. But then what is security? What is the problem? Why is it so difficult? And what does a complete solution look like? This is precisely where SAMM comes in. SAMM gives you a practical way to measure your current security posture. Once you know where you are, SAMM can help you plan and improve in an incremental fashion. And then precisely because of this measurability, SAMM allows you to demonstrate these improvements in a quantitative way. Moreover, we, the SAMM core team, strongly believe that SAMM aligns exceptionally well with the expectations of the European Union's Cyber Resilience Act. So whether you have heard of SAMM or not, this session will give you a clear introduction and point you toward the best next steps for learning more. So strap in and let's get into it. Let us quickly revisit the actual problem. In other words, what makes application security such a complex endeavor, and what are the main reasons behind that? Applications are often one of the most common attack vectors today, and it is not hard to see why. Modern software is complex. We have things like microservices, APIs, cloud environments, containers, and so on and so forth. All of this is stitched together into fast-moving and highly dynamic systems. We are also racing to adopt new technologies like AI, 5G, often before we fully understand the security implications. On top of that, there is a constant push and pull between three competing priorities: cost, speed, and quality. And security is a quality. And more often than not, it's quality that actually gets squeezed. To make things worse, security is one of the qualities that gets even less attention because it is much harder to perceive. You can see usability and even add metrics for usability. You can check performance using, for instance, stress testing. However, security is less tangible. So you can't really see or check for security. Well, you can, but then it's sort of too late. And this is when things become more obvious, when you have had a data breach. But then after all, why do we really care? Well, when security fails, it's not just an IT problem. It becomes a business problem because it is gonna hurt the corporate bottom line. Aside from fixing the issue, which could be simple fix, but it could also involve a design problem, which is gonna be much more difficult to fix. There are also things like direct fines from regulators, loss of trust from your customers and reputational damage. Even stock price could get a hit. Now let's have a look at security in the software development lifecycle. A software development lifecycle is a structured process that focuses on producing high quality software fast and cheap. So referring to the triangle that I presented earlier, it's about optimizing that triangle and not simply ignoring the quality. In a traditional software development lifecycle, there are some phase gates when it comes to security. Nowadays, we often see various sorts of scanners during the build and test phases. Clearly, there are pen tests in place. For the maintenance phase, we have patching. Unfortunately, this is not enough. It is not cost efficient, and there is no real security assurance behind this. A typical example is when we are ready with the development of a software system, then we pull in the pen testers, then they find some issues just a couple of days before the release, and all hell breaks loose. That is not the way to approach security. This is exactly what we are trying to get away from with this idea of secure by design. And secure by design doesn't mean that you're just going to deal with security during design. It is in fact a systematic approach to security which is practiced throughout the entire development lifecycle. It is about consistency and a holistic approach at the organizational level. The cornerstones of any application security program are, first of all, getting the right people in the right roles, making sure they understand their responsibilities and supporting them to accomplish those responsibilities. Security is, to a certain degree, everyone's concern. Giving these people low friction, pragmatic processes is the next most important thing. We want people to care about security, but we know that if we require them to do things that are burdensome to do, they will find ways not to do them. But we do want to have our checks, a few gates that we do have in place to be really substantive. Then the knowledge base, making sure people understand where their compliance requirements are, that the coding standards are driven by a quality concern, and so on. Obviously, tools can help you automate and speed up things, and tools come in the picture at the very end. Actually, once you already have your processes in place, you bring the tools to make things go faster, to help the people do their job better. And now, of course, what we're really talking about is risk. Everything about security is a risk management function. The things that we're asking people to do are meant to drive down the risk. Security features are meant to address risks. And of course, we want to make sure that all of that is well understood, so the investment in the required training needs to be there. Let us look briefly at the history and, more importantly, the vision behind OWASP SAMM. Above all, SAMM provides measurability to your security practices and overall security posture. So you can use SAMM to evaluate how your organization is doing in terms of their existing security posture. With the 90 questions from SAMM, you can come up with a single score that says how mature your security practices are. Obviously, SAMM is actionable, so you can build a balanced and iterative software security assurance program without getting overwhelmed by the breadth and the depth of application security challenge. And finally, and more importantly, SAMM is independent of a technology, process, organization size, industry. So it fits in any context where application development and operations is relevant. Even in a shared responsibility context where an organization is buying and customizing software. Let us briefly talk about why do we need a maturity model. Here are some core principles that provide a motivation of the way SAMM was structured. The first observation is that an organization's behavior changes slowly over time, and trying to boil the ocean is never going to work. So changes need to be small and iterative to really take hold and make a difference. Secondly, there is no single recipe that works for all organizations. It cannot be a laundry list of doing all these things and you're gonna be good, which is something that we often see in compliance and checklist-based security frameworks. It has to be more around what sort of risks are you trying to address, what are your executives' priorities, and how does that fit with what we should work on first. Third, and finally, guidance related to security activities must be prescriptive. And that is really what SAMM offers. It is a simple, well-defined, and measurable approach. SAMM's history starts many years ago in 2009. Version 1.0 was originally created through the Open SAMM project led by Pravir Chandra, who was an independent software security consultant back in the time. Around 2015-2016, a group of OWASP volunteers got involved, and it was agreed that OWASP would fork SAMM as an official OWASP project. Pravir is still the steward of Open SAMM, although there hasn't been a revision of it. So both projects exist, just to make it more confusing. But do remember that the most recent version of the project is called OWASP SAMM and not Open SAMM. There has been quite some work put in the project. We had version 1.1, 1.5, and eventually the most recent version is 2.1, which was released in 2024. The key thing to remember here is that the project is a community effort. It's an open source project. Anyone is free to get involved, to submit GitHub issues, to submit pull requests, and help us improve the model even further. Now that you know all about SAMM's vision, let's unveil the model. SAMM has a very symmetric structure. There are 5 business functions, and under each business function, there are practices defined. Under each security practice, there are 2 streams, and there are activities at each maturity level under each stream. It is important to mention at this point that despite the fact that the streams are called stream A and stream B, these are just grouping of security activities in logically coherent buckets. There is no inherent relationship between the streams. It is not the case that you have to first implement stream A and then focus on stream B. This is what the full model looks like. Now, it is very big and very extensive. On the other hand, though, this provides a full picture of everything there is in terms of application security when you're developing software. There are 5 business functions, as I've already mentioned, and each business function should resonate pretty well with any stakeholder involved in the software development lifecycle. Governance focuses on processes related to how an organization manages overall software development activities. Design is about processes related to how an organization defines goals and creates software within development projects. In general, design will include a clear understanding of both business risk and technical risk, as well as security requirements, high-level architecture, and detailed design. Implementation focuses on processes related to how an organization builds and deploys software components. Verification is about activities related to how an organization checks and tests artifacts produced throughout the development process. Finally, the operations business function is about making sure that confidentiality, integrity, and availability, in other words, security, are all maintained throughout the operational lifetime of every application and their associated data. Let us zoom in on one specific security practice, which is secure build. And more concretely, we're going to look into one stream, which is the build process. Every stream has 3 successive objectives that define how it can be improved over time. These are typically ordered by increasing cost and difficulty, and that establishes a notion of a level at which an organization fulfills a given practice. So looking at the levels, which is the left part of this slide, we start actually at the level 0, which is implicit, which means you are not doing anything for this specific stream. Level 1 is ad hoc provisioning. You understand you should be doing it. Some of your teams are perhaps already doing it, but overall your approach is ad hoc and not well structured. At level 2, you do have a structured mechanism for implementing a specific stream, but you're not yet fully mastering this practice and this stream. Level 3 means you have good metrics in place, good feedback, you're reviewing your processes, and you are continuously improving, so you are mastering a specific stream. For most SAMM streams, every next level builds on top of the previous level. So in order to achieve the next level, you have to fulfill everything there is on the previous level. Now, a key remark here is that not everyone needs to make it to level 3 in all areas. The goal is absolutely not to max out every stream and every practice. The target maturity, or where you need to get, is dependent on your organizational context and risk. Now, what does good look like for the build process? At the first level, this is still an ad hoc approach. You have a formal definition of the process so that it is very consistent and repeatable. Moving on towards the second level, your build is fully automated. It is hands-off. Ideally, as soon as the pull request is merged, the build starts. Finally, at the highest level of maturity, you also want to automate your security testing to be part of the build pipeline. As I have already mentioned, SAMM contains 5 business functions. Each business function has 3 security practices, each practice has 2 streams, and every stream is made up of 3 activities, like presented on this slide. This gives a total of 90 SAMM activities, and the SAMM assessment process is sort of built directly into these activities. For each activity, there is exactly 1 assessment question. Each question is asking pretty much whether you are doing this activity. Let's look at the SAMM assessment question for the build process maturity level 1. The question for this activity is whether the build process is formally described. In deciding how to answer, you are looking at two things. First of all, across what portion of the organization is that thing being done? So in many cases, the answers will say, no, we are not doing that. Or yes, we're doing that for some of our applications, at least half of our applications, or most or all of our applications. In order to answer this question, you have to be clear what applications are in scope for the assessment. And yes, if you have only a single application, your answer will typically be either no or yes for most or all of the applications. The second dimension in order to answer the question is the quality dimension. In essence, quality criteria are the definition of done. For the build process level 1, you need to have build documentation that is up to date and that is accessible. Your build has to create artifact checksums, and finally, you have to make sure that your build tools are hardened, which could mean, for instance, nobody can modify the build process, or that you're taking good care of any secrets that are required in the build process. The scoring of SAM assessments is relatively straightforward. You get 0 points for a no answer, 1 point for the most or all applications answer, and then partial credit for the in-between answers. Within the stream, we take the sum of the 3 question answer scores, and then we average them out across streams, security practices, and business functions. Once you answer all 90 questions, you can then visualize your security posture with this sort of scorecards. This allows you to evaluate where you currently are, and based on your risk profile and your risk appetite, you can create a gap analysis versus where you need to get. You can also build a balanced improvement program based on these scorecards and, more importantly, demonstrate those improvements. Keep in mind that especially in large organizations, in order to justify your security budget, you must have this sort of reporting in place. More than that, we are aware of SAM assessments being used for merger and acquisition assessments. Before buying a company, you can estimate what is their security posture using SAM. And last but not least, we have also recently heard of a story where SAM was being used to negotiate cheaper cybersecurity insurance premiums. Understanding SAM and doing an assessment is actually, and unfortunately, the easy part. Unless you plan on doing the improvements, it doesn't really make much sense to do the assessment. We're going to present here briefly a generic approach for using the model. This is a repeatable process. However, as an organization, you can adapt it and decide what each of the steps means in the context of your organization and go ahead with that. The key part of a SAM assessment is understanding and defining the scope of the assessment. That could be an entire line of business, a team, or even a specific application. Once you have determined the scope, you must identify which stakeholders are you going to need in order to answer every question in your assessment. It is unlikely that one specific person will be able to answer every single question across the SAM assessment. The next step is doing the assessment, which we have already briefly discussed, 90 questions in order to evaluate current practices and determine the maturity level. The next step of the process could be very challenging. Setting the targets. It is out of the scope for this introductory video how to set the targets, but once you have set the target, you need to estimate what is the overall impact. We would recommend setting realistic targets and not trying to get many things, many activities improved all at the same time. Once you have set your targets, you need to define a plan how to get there. And this is very much organization specific. The next step would be implementing these activities and finally making sure that they are well integrated in your software development lifecycle. And then we repeat this cycle where we redo an assessment, whether that is a full assessment or in a more typical setting, you would reassess only the streams, only the practices that you have improved. And it is a good idea to measure how effective these new improvements are. Now, outside of this introductory video, there is also a full SAM fundamentals course, which is a self-paced training available online, which includes information on the details of every SAM activity, as well as a quiz to help you get more hands-on feeling of how to do SAM assessments. For more information about the project, the full model itself, guidance, resources, please check out our website owaspsamm.org. We would also highly recommend you to join our Slack channel, where the full core team is available for any questions you might have. We organize monthly community calls every second Wednesday of the month. Those calls are available through Meetup. Consider subscribing to our YouTube channel, where you can find a lot of interesting resources about the model, practical tips, how to do assessments, guidance, benchmark updates, and so on. And finally, consider joining our newsletter to stay up to date with the latest news and events that we organize. Thanks for watching this introductory video. We hope to meet you and see you soon.